Hello everyone, welcome to week 5, lesson A. This lesson is called Match a Sequence with a Table using Rate of Change. And our goal today is going to be to use the common ratio or the common difference to describe rate of change. Common ratio is when you find the next number in a sequence by multiplying. Common difference is finding the next number in a sequence by adding or subtracting. Our agenda, I'm going to give you a warm-up and I'm going to show you a table. I'm going to ask you what is the same and different about the tables. We're going to do an exploration with graphs and tables today and then a final reflection. Today's warm-up, similarities and differences. Describe for me the similarities and differences you see between the two tables, Table A and Table B. Let's now take a look at these two tables. We have Table A and Table B. And you can see that on the table, they have an X with a 0, 1, 2, 3, 4. And then the Y values 2, 6, 10, 6, 2. X would represent the number of the term 1, term 2, term 3, etc. Y might be the number of circles for each term. Same thing for Table B. These tables are written horizontally. Sometimes tables are written vertically. But we want to know what is the same about these two tables. We'll take a look at the changes. This goes up by 4. 6 goes from 10. That goes up by 4. 10 moves down to 6, down by 4. And then 6 goes to 2, so again, that's down by 4. Over here, you go from 2 to 8, so that's plus 6. 8 to 10, plus 2. 10 to 8, minus 2. 8 to 2, minus 6. So these are up, down patterns, so they are quadratic. So that is how they are the same. How they are different, the rate of change is not consistent. Okay. Over here for Table A, you have 4 jumps in between the numbers, but for Table B, you have 6 jumps and then 2 jumps. All right. So the rate of change is quite different between the two tables. We are going to explore Sequence A. Sequence A has circles. Can you find the pattern in the circles and continue the pattern? How many circles would be in term 5? You can also record how many circles there are on a table. X would be the terms, term 1, 2, 3, 4, 5. Y is the number of circles. So that way you have the independent and the dependent variable. I want you to tell me how many circles go in the table for term 5. Now take a look at graph A. Graph A is a picture of what's going on with the circles. You can see term 1 has 2 circles, term 2 has 4 circles, term 4 has 8 circles. If I wanted to continue the pattern, can you extend the line and tell me how many circles for term 5? Can you explain your reasoning? How did you find the next number in the pattern. Can you describe for me the overall rate of change? Sequence B. Continue the pattern. Can you find the number of circles in term 5? Table B. Can you record, using a table, the number of circles you found for term 5? Notice that the table matches the number of circles. 1, there were 16 circles. For term 2, there were 8 circles, etc. So when you find the number of circles in term 5, you can put it on the chart or the table. Graph B. This is a picture of how many circles in each term. At 1, there were 16 circles. Can you continue the graph? Can you extend the line to show me how many circles in term 5? Can you explain your reasoning? How did you know how many circles to put in term 5? Can you describe the overall rate of change? Sequence C. Can you find the pattern in the circles and draw in how many circles would be in term 5? Table C. Can you record the number of circles for term 5? Graph C. Can you draw a picture? Here you can see at term 1 there were 4 circles. At term 3 there were -4 circles. Can you continue the picture and draw on the graph how many circles at term 5? Can you explain your reasoning? How did you find the number of circles at term 5? Can you describe the overall rate of change? Sequence, table, and graph are all linear. To continue the pattern, term 5 needs 10 circles. If you work with the sequence, you can see that +2 circles is being added every single time to the last number of the sequence. You can then record the circle information in a table. X represents term 1, term 2, term 3, etc. And then Y represents the number of circles. So when you get to term 5, you can record 10 circles. Over here for graph A, you can visually represent the sequence. X would be the number of the term in the sequence, that's your independent variable. Y would be the number of circles, that's the dependent variable. You can then see that this sequence is increasing by 2 each time. It goes from 2, 3, 4, so every circle plotted or every dot plotted on this graph goes up by 2. Every time the term goes over 1, it goes up by 2. Over one term, up by 2 more circles. So if I want to, I can then record at 5, 10 circles, and I can continue my line. The next pattern that we looked at was exponential. Sequence B, table B, and graph B represent exponential functions. To continue the pattern, this one is a little tricky. You have to take half of the circles each time. So from term 1 to term 2, the sequence went down by 8. Then it went down by 4. Then it went down by 2. So it's being cut in half each time. So half of 2 is 1. So there'd be 1 circle at term 5. Very tempting to put 0 there. Our X and Y table, X is the number of each term, Y is the number of circles. So again, at term 5, you can record 1 circle. Over here for graph B, we can go ahead and continue our graph. Our graph this time is decreasing. You read a graph from left to right, just like you read the sequence left to right, just like you read a book. So at term 5, we can plot 1 dot here, or a dot at 1. 1 would be halfway between 0 and 2. You have to see how your scale is being increased over here on the y-axis. So it's counting by 2's for every line. So right here, our dot would have to be halfway. So 5 is at 1. Our last example was quadratic. A quadratic sequence goes down and then up, or up then down. So you can see that clearly right here. We have 4, -2, -4, -2, and then 4 circles. Okay. So this basically went down by 6. Okay. Then it went down by 2. Then it went up by 2 circles, and then it went up by 6 circles. So you can continue the pattern. It's symmetrical. So if you knew there were 4 circles in term 1, you can then record 4 circles in term 5. You can see the information represented in a table. X is the number of the term, Y is the number of circles. So at term 5, we can record 4 circles. Over here on the graph is very easy to continue. It's going to finish back up where it started at 4 circles. So here's 1, term 2, term 3, term 4, term 5. And at term 5, we have 4 circles for this quadratic function. Our closure question today: describe the similarities and differences in how the two tables are changing. We have table A and table B. How is the change in the table the same? How is the change in the table different?